In this video, we will build the exact foundation you need before understanding RAG systems. First, we will understand what an LLM actually is. Then, we'll go and break down how LLMs predict answer using probabilities and patterns. After that, we will explore where LLMs are actually useful in the real world. And finally, we will uncover the real enterprise AI problem: outdated knowledge, hallucination, private data limitation, and why retraining is not the real solution every time. By the end of this video, you will clearly understand why RAG becomes necessary in modern AI system. But before I begin, I will strongly recommend you to go and visit the introduction video of RAG Mastery Playbook, which is already there in the playlist, so that you understand the context and what to expect from the entire series. So stay tuned till the end. LLM stands for Large Language Model, and in this image shows that how these systems are trained. Notice the different data sources feeding into the model: books, website, research paper, human conversation, and even programming code. Modern LLMs are trained on billions of words collected from across internet. And during the training, the model learns patterns, relationship, language structure, and how words statistically connect to each other. That trained system at the center is what we call an LLM. The model learns pattern by seeing billions of examples. For example, after the word hello, the word world often appears next. And after a question like what is 2 plus 2, the answer 4 is statistically very likely. So the LLM is constantly predicting the next most probable word based on learned patterns. This is the most important thing to understand about LLMs. The model does not actually know the facts the way humans do. Look at this example. When the input says the sun rises dash, the model predicts that the next likely word is east. Not because it understands astronomy, not because it knows this like human does, but because during training it saw that pattern billions of times. And notice the probabilities on the right. The model evaluates multiple possible next words and then selects the statistically most likely one. So an LLM is not thinking, it is just predicting one word at a time over and over again. So when we ask an LLM a question, it actually looks at everything it learned during its training. Then it calculates which possible answer is statistically most likely. Notice the probability score in the center. The model compares multiple possible answers and then select the one with highest probability. So the final answer is not based on true understanding. Here's the difference, please notice it. It is just based on prediction, statistic, and learned patterns. Most of the time, this prediction process works extremely well. The model has seen similar patterns many times during training, so the answer is usually correct. But sometimes the model confidently predicts the wrong answer, and that is where hallucination happens. The AI sounds intelligent and confident, even when the information is actually incorrect. A hallucination is when an AI sounds completely confident while saying something that is not actually true. Notice the student example here. If a student genuinely knows the answer to what is the capital of India, then he confidently says New Delhi. But if they don't know, an honest response would be I don't know. An LLM behaves differently here. Even when it is uncertain, it still tries to generate the most likely answer based on the pattern it has learned during training. And because the response sounds fluent and confident, we naturally tend to trust in it, even when the answer may be actually wrong. And here is why hallucination happen. Once an LLM finishes its training, its knowledge becomes frozen. That means the model does not automatically learn new information after the training is complete. Think about the ice block in this image. It presents the frozen knowledge. The AI can still answer questions, but its knowledge is locked to whatever information existed during training. So if new information appears later, the model simply does not know it yet. This creates a major problem for real-world AI system. Imagine your company updates an internal policy yesterday. The LLM does not automatically know that update. Or imagine a new scientific discovery happens today. Again, the LLM does not know about it. Because once training is finished, the knowledge of that model is frozen in that time. And here is the most expensive part. To teach the model new information, you cannot simply upload knowledge into it. You have to retrain the model. And retraining large AI model can cost billions of dollars, take months, requires enormous computing power. That is where core scalability problem with large language model appears. Companies generate new information constantly, new policies, new documents, new decision, new research, but you cannot retrain GPT every single time new information appears. Look at this process in the middle. To update the model, you must retrain it using enormous dataset and massive computing infrastructure. And retraining large models can cost millions of dollars, take months, and it can require huge GPU resources. At enterprise scale, that simply becomes impossible. There is another major problem with retraining LLMs. Companies have highly sensitive private data, internal policies, customer contract, financial record, confidential research, or maybe strategic information. Now, these data cannot simply be sent to a public AI company for retraining. That creates serious privacy and security risk. And for many enterprises, that would be a complete privacy disaster. So, now we have a real enterprise AI problem. One side, your AI is either outdated, meaning it does not know the latest information, or it starts hallucinating, confidently generating the answer that may be wrong, or it cannot access private company knowledge at all because the data is locked behind security and privacy boundaries. And these three problems are exactly what push the industry towards RAG system. So in this section, we understood the real limitation of LLMs, why AI becomes outdated, why hallucination happen, and why enterprises simply cannot retrain models with private company data. But now comes the important question. What exactly is RAG and how does it actually solve these problems? In the next section, we'll break down what RAG really is, how retrieval works before generation, and why enterprises became so obsessed with this architecture. I will see you in the next section. EdgeTalks, clarity that moves with you.